Welcome to this DGCA ground school session. I am Captain Pankaj, and today we are breaking down the exact procedures governing Aerodrome Control Service. Aviation leaves zero margin for error. A modern aerodrome functions through strict procedural adherence because instinct alone cannot manage this level of complexity. Aerodrome control towers issue information and clearances to achieve a safe, orderly, and expeditious flow of air traffic. The objective? Prevent collisions. Controllers separate aircraft in the circuit, on the maneuvering area, landing and taking off, and vehicles or obstructions on that area. Safety at this level requires enforcing a rigid spatial matrix upon a dynamic environment. Everyone must know exactly where their authority begins and ends. The control tower operates as a synchronized team with strictly delineated zones of authority. This chart divides responsibilities. The aerodrome controller handles active runways and airborne traffic. The ground controller handles the maneuvering area, explicitly stopping at active runways. Clearance delivery manages startups and ATC clearances. For parallel runways, individual controllers take responsibility for each specific runway. When that standard flow breaks down, we activate Section 2, the alerting service. This is the specific fallback system for managing emergencies. The tower alerts rescue and firefighting services under 4 triggers. First, an aircraft accident has occurred. Second, information suggests an aircraft safety is impaired. Third, if specifically requested by the flight crew. And fourth, whenever ATC deems it necessary based on continuous watch. Tower controllers operate on these precise, non-negotiable regulatory tripwires to ensure emergency services deploy the moment risk escalates. Let us move to the cockpit and follow the chronological journey of a departing aircraft. Section 3 covers pre-clearance obligations. This diagram outlines the departure sequence. Before requesting startup, step ladders and aero bridges must be removed, doors closed, total persons on board intimated, and security checks confirmed. Regulatory delays may follow. Pushback waits for adjacent aircraft, prescribed separation behind preceding traffic, or overflying aircraft. There is an explicit exception to this sequencing rule. ATC is permitted to deviate from the standard order to facilitate a VIP aircraft movement. By integrating these separation rules, pushback delays, and priority exceptions, ATC maintains a departure flow that prioritizes volume without compromising regulatory safety. Section 4 dictates the absolute rules for takeoff and landing. A pilot in command cannot take off, land, or even run up engines on the active runway without explicit authorization from aerodrome control. Look back at the sequence diagram. To minimize runway occupancy time, all cockpit checks should be completed prior to lineup. Once the takeoff clearance is issued, the pilot must be ready to commence the takeoff roll immediately. Arriving aircraft are also expected to execute rapid exits, allowing ATC to apply minimum spacing. Furthermore, heed this DGCA exam alert. Cruise climb, along with transonic and supersonic flight phases, are strictly prohibited over Indian airspace. Immediate pilot compliance with clearances directly dictates the capacity and safety of the entire aerodrome system. Moving up from the ground and into the air, Section 5 outlines designated positions within visual and taxi circuits. This diagram illustrates the standard visual traffic circuit, a predictable loop of upwind, crosswind, downwind, and base legs. The final approach extends 4 nautical miles. Crucially for DGCA exams, aircraft must report long final between 4 and 8 nautical miles from the threshold. By utilizing this standardized circuit, ATC transforms dynamic, 3-dimensional airspace into a highly predictable, manageable loop. We return to the highest risk phase of operation, ground movement. Sections 6 and 7 govern how aircraft navigate the taxiways. This graphic demonstrates a critical DGCA exam concept for runway crossings. If a taxi route crosses an active runway, the clearance must contain an explicit instruction to cross. You cannot assume a crossing clearance. Without explicit instruction, the pilot must hold short. When an aircraft does cross or vacate a runway, the pilot can only report clear when the entire aircraft, tail included, is completely beyond the relevant holding line. Section 8 establishes strict runway holding positions to protect traffic. Memorize these DGCA exam metrics. For runways 900 meters or greater, the holding position is a minimum of 50 meters from the edge. For runways under 900 meters, the minimum distance reduces to 30 meters. Preventing ground incursions demands explicit verbal communication, combined with unyielding adherence to those painted physical limits. The final cognitive layer of departure is the precise flow of environmental data from ATC to the flight crew, outlined in sections 9 and 10. This infographic details how information is fed in sequential packets. Node A covers pre-taxi information. Prior to taxiing, ATC provides the runway to be used, surface wind, air temperature for turbine engines, visibility, and correct time. Note the QNH altimeter setting is provided on a regular basis. QFE, however, is only provided if specifically requested by the pilot. Section 10 shifts focus to Node B, the pre-takeoff information. Right before the aircraft commences its takeoff roll, the required data changes. At this stage, ATC will only interrupt to provide significant changes in wind, temperature, or visibility. They will also issue warnings for severe meteorological conditions, like cumulonimbus clouds, wind shear, hail, or severe turbulence in the climb-out area. Feeding this information sequentially ensures the flight crew receives exactly what they need, exactly when they need it, preventing cognitive overload during the most critical phases of checklist execution. From clearance delivery, down the taxiway, to the holding line and onto the active runway, every procedural gate builds upon the last to create a unified safety net. The DGCA exam tests your precision within this system. It punishes those who mistake assumptions for explicit regulatory clearances. Know the distances, know the boundaries, and respect the triggers. I am Captain Pankaj-Pahil. Study hard, fly precise, and I will see you in the next session. Professional aerodrome control is the direct result of following this established procedural matrix, where every movement is governed by a specific regulatory clearance.